is usually a function of labor hours and machine hours. Okay? And again, that implies that it's what hours is really driving cost, the cause and effect relationship between the hours and the cost. That's implied in using that kind of approach. So when you incur a labor hour, that means you have more overhead. That's the simple assumption you're making. This approach, ABC, is going to look at something beyond just labor hours. It's going to look at things like, there are different measures they're looking at that are not necessarily related to labor hours that may drive costs. For example, some products require machine setups of more machine setups in a year than other products, a day than other products. So let's say, for example, we have product A. Product A, there may have to be 10 machine setups a day to run product A, to produce it. Whereas product B, there only have to be 3 machine setups. And so in setting up the machine and getting it ready for the product, that may involve all kinds of costs. So wouldn't you like to allocate more of the machine setup costs to those products that require more machine setups? Absolutely. Those costs are not driven, however, by direct labor necessarily. They may be driven by other factors that lead to the cost of those machines, not necessarily labor. So there's an example. There's an example where if you can take some of the overhead that's associated with the machine setups, we call those batch costs. Batch costs. We can get a better allocation method going of cost to products, more accurate, more cause-effect relationships. Again, that's the goal: cause and effect relationships between the cost object, which is the product we're trying to measure, and the cost that occurs. Here's another example. There's something called product design costs. So there's certain products that the product design costs are much higher than other products. So you don't want to just take all the product design costs and allocate it by labor hours. You want to figure out which products have higher design costs than other products, and make sure that those products are getting more of their share of the product design costs. Again, that's not necessarily labor hours. So basically what ABC is trying to do in so many words is take, actually not just fixed overhead, all overhead, and allocate it to the products in a more meaningful way. Instead of in one lump sum, we're going to disaggregate overhead into more meaningful pieces and figure out cause and effect relationship between the cost and a new type of driver for each of those costs. That's all it is. It's just refining and disaggregating a lump sum of cost into more finite units where we can see a cause and effect relationship. That's all it is, in so many words. That's what ABC does. It's very common sense. And so, let me kind of show you, bear with me. So 4:30. I'm cutting out at 4:30. Is that too late? You guys okay with that? So it's designed to provide managers with cost information for various decisions, and hopefully, basically provide more precise information now, that we've had trouble with measuring in terms of the products that we're producing. Now, certainly in a hospital, it's got to be. You have so many different services and so many common costs, and so many. To the idea of somehow appropriately measuring the cost of the services that you're providing in a meaningful way, so that a decision maker can look at these things and say, "Ooh, we're only getting so much revenue from DRG or whatever, and these are the costs we're incurring. What should we do?" So you need to be able to measure these things to make decisions. So in a traditional costing approach, you basically allocate the manufacturing cost to the products the way we've seen in Chapter 4, using predetermined overhead rates typically. That's the way it's done. And at ABC, though, notice you're going to take both manufacturing and non-manufacturing and try to find ways to allocate them to the products because in a cause-effect relationship between the cost drivers and the costs. Notice under ABC, not all manufacturing costs are necessarily allocated to the products, whereas under the absorption method they would be. So notice this.
Why wouldn't they?
Because you'll see it's not, some of those may be common. Those costs may not be necessarily, those may be the kind of costs that don't lead to decision making because you're going to incur them either way.
It's like going back to the idea of having sunk costs or...
And that's
right?
a way of thinking about it, yes. The point is you can't make decisions with those costs anytime in the near term.
Like under traditional, you would have to pay for, you would allocate the cleaning crew of the factory to each product. But with ABC, since you would need the cleaning crew anyway, you don't do that, it's just common.
Well,
like,
that could be the case, but that's the idea. Anything that doesn't lend itself to providing better decision-making ability is potentially, we don't treat that as part of the allocation cost. We typically call these, the costs you should know, by the way, in advance, that we're not going to allocate, they're called, I think they're called facility costs. Facility costs. Those are common, that's their term in this chapter for a common cost. These are called facility costs that you're going to incur. You'd have to get rid of the whole firm to get rid of these costs. So these are the, so you're going to do a problem which basically looks at both this and this. This and this. This is a step up. Your problem is going to ask you the departmental, which is it's better than a plant-wide rate. It's a little more refined. This chapter takes us to a new level of complexity and sophistication. ABC.
Oh, you're saying from chapter 5 we're doing...
Chapter 4, I believe, is going to ask you to do both. The problem I assigned you in chapter 4 looks at both this and this. In chapter 6, we're moving now to another level of sophistication, so-called ABC. So this is the game that academics are talking about now, the ABC. So each ABC, they're using terminology, so hopefully it's, cost pool has its own unique measure of activity. All that's saying is that we're looking at a cost pool that has its own cost driver, they're not necessarily labor hours. Traditional cost systems usually rely on volume measures such as labor hours and machine hours to allocate all overhead costs. So we're moving away from that with ABC. Very simplistic, not accurate. So ABC is going to disaggregate overhead into more pools. Therefore, it's hopefully more accurate, more refined. So this, a couple of terminology. Activity, it's an event that causes the costs to occur. And activity cost pool, we use this term to talk about a segment of the overhead that we've been using, and we're disaggregating into pools, different pools. Not just one big pool, into different separate pools. So a cost bucket in which costs related to a single activity measure are accumulated. How costs are treated under ABC? The term cost driver, which I often use, is used to refer to an activity measure. Some people say an allocation base in an ABC system. ABC defines 5 separate levels of activity that are not due to volume. So that in itself is the critical thing. We're moving away from one single measure, labor hours, machine hours, as the sole way we're allocating overhead. That's ABC moves away from that completely. It's got 4 or 5 different approaches now, measures that it's going to use. A unit level is the old traditional one. A batch level is what I described with machine setups as an example of a batch activity. How many machine setups does each product require? Product level activity, this is what I said, like designing issues. Designing products would be product level activity. This is the organization sustained. This is not going to be allocated. This is the cost that stays unallocated because you have to get rid of the whole organization to avoid these costs. So this is the pool of unallocated costs. And then customer level, that's related to different products at different customer level expenses. Meaning, maybe some customers require more hand-holding with certain products than others, more servicing, more whatever. So different products have different customer activities, so we want to isolate that cost of customer level cost and make sure we allocate it to the products which have the most requirements for those costs. Not just put it all into a big pool of cost and allocate it by labor hours. That doesn't get you anywhere, really. Okay, I don't want to get into this. This is okay. So here's an example of ABC. This is the old-fashioned absorption costing statement. Cost of goods sold, direct materials. Actually, it's breaking it down into the. When you see gross margin versus contribution margin, that tells you it's a traditional income statement. Selling administrative and net income. In this case, a loss. It says here, manufacturing overhead is allocated to products using a single plant-wide overhead rate based on machine hours, similar to what we did in Chapter 4. So in this case, this company has, they've broken things down into different pools. They have a cost pool called customer orders, and it's going to be allocated based on the number of customer orders in each product. Some products may have more customer orders, some products may have fewer customer orders. The ones who have more are going to pick up more of these costs. Design changes, we're going to focus on the number of design changes for each product. So the products that require more design changes are going to pick up more of the design changes costs. So ultimately, we're going to try to allocate, we're going to try to end up with cost pools for each of these guys, and then we're going to have the activity measure, and we're going to allocate it to different products based on different measures. So it's not all just labor hours anymore. It's things like number of customer orders, number of design changes. We have one for machine hours, so we haven't completely abandoned that one. Number of active customers, so we do have different measures that are not necessarily driven by this. Okay? And that's, believe it or not, that's the critical feature of this approach. That is what makes this approach unique. It moves away from a simpler to a much more complex, hopefully better approach. So one of the things we're going to do is we're going to allocate all the costs, traditional costs, to these pools in some way. So that's what they call we're going to basically do a first stage allocation. We have to create these cost buckets. First step, we need to create costs in the cost buckets before we allocate anything. So that's not easy to do, but somehow under this approach, we have to figure out, go back. We have to figure out how much cost should we have in this cost bucket, how much cost should we have in this cost bucket. So that is not just given to you, you have to measure that in this system. Take a look at this. So we're not going to allocate, obviously we're not going to allocate direct labor, direct materials. The only thing, so everything else is fair game. Everything else is fair game under this system. Now this system, by the way, I'm not saying you should use it, but in theory this system makes a lot of sense. Now it's hard to implement it, and I don't care if you have a service company or a manufacturing, but this system is going to give you better cost allocations that are accurate. So you should be able to, in the real world, make decisions like, again, we're offering this service, is this really generating is this adding to the bottom line? Or not? So this is the tricky part of this problem, in the real world. You take every cost you've got, except for direct materials, direct labor, and you figure out somehow, based on some internal measures, what percentage of those costs should go into each of these pools. This takes maybe an engineering approach, maybe you need an engineer to help you figure this out. But ultimately, once you figure out these percentages, you can then use this method. So we're taking every line item you saw before and going to somehow figure out how much of these belong to each of these products. So for example, 30% of the indirect factory wages is going to customer orders, 30% is design changes, 20% to order size, 10% to customer relations, and then other, which is the non-allocated costs, 10%. So we start with our traditional costing system, which we have these dollar amounts, and we're going to allocate these, what they call the first level allocation, to the cost buckets. That's the first thing we do. We have to allocate the traditional costs, not direct material, not direct labor, but everything else, into each of those different cost buckets that we have.
So what is other, how does other get accounted for?
Other is not going to be allocated.
Like overhead? Like
It's
a real overhead?
It's like common cost, ignore it.
Common.
How does it make sense to have indirect factory wages
Good question.
as
Customer orders? I don't know.
and design changes and customer relations? Like, that's not where you're dealing with customers at all.
They've, again, through an engineering kind of analysis, they've decided that they found out that customer orders is related in some fashion to indirect factory wages. It does lead to perhaps to production. It does
I know,
affect.
but customer relations doesn't.
That's why it's only 10%. But these are the questions that I want you to ask. But this is a mythical kind of thing. This is not the real world. So, accept this as a mythical example, which
It's a
your
unicorn.
question. I'm glad you asked the question because you're right. I asked the same question. Sure. How is indirect factory wages to this one? But anyway, assuming it is, you can take all your costs and put it into each of these buckets so that so for example, you have indirect factory wages of 6 million, and you want to go back and see how much of that should be go into the bucket called, go back a page up. So how much of the 6 million should go into customer orders? 30%. So there it is. So customer orders, as part of its cost bucket, will end up with 1.8 million for that particular item. So we're going to go down the list of all these different costs and allocate them to these different cost buckets. So there's a question. That's what they call a first stage allocation
And you
approach.
treat that as a fixed cost for that thing, or then you divide it up as a...
Well,
cost?
once we end up with the cost bucket costs,
Then you...
we allocate it based on those measures that we looked at.
And then any difference, you just dump it into common costs.
Yes. I'm going to do you guys a favor. I know I shouldn't, but I think this is a good stopping point. I want you to look at this chapter. I think what I've told you is more than enough to get you started to thinking about this chapter. Next class, we will pick up where we left off, and I'm not going to spend a lot of time in chapter 6 because I think it's an interesting concept, but it's not. Ultimately, it's one that I just want to give you a taste of. You're not going to be doing this in practice, but let's spend the next class starting with this chapter. I'll give you a problem to work on, the usual thing, to see if you can do it, and then we'll move on to chapter 7. Thank you, guys, and again, my apologies for being late. Thank you very much. I'm hoping now to get home in a more relaxed manner. So we will not, I repeat, not meet next Sunday.
This is yours. Is that your phone, Marty, and my charger?
Yes, it is. I will give you back your charger. Thanks.